All right, so I think this one should be the last one we cover today. And this is called median filter. So median operation, I think you should all know from your basic maths. All right. So what median filter will do is, in that neighborhood, instead of computing average or any linear combination, it will just select like the median value. All right. So we'll see like what are the advantages, and it's not same as convolution because we are not actually using the neighborhood values. So let's look at this simple example. I think it will be more clear. So in this case, when you are using mean filter is like you have a one like at all the places, right? It's normalized, and we know it gave you 50. Okay, what if we use like a median filter? Now median filter will actually take all these pixel values in the neighborhood. So we just have 0 and 90, and it will pick the median value. And in this case, you can easily see that you have 4 pixels which are black, 4 pixels which are white, or sorry, 5 pixels which are white. So definitely the white pixel is the median. All right, so the value will be 90 if you perform median filtering. Now, let's look at the example and try to understand like why median filter is better. So on the y-axis over here, this is just showing you the shape of the kernel. Right? So this is 3 cross 3, 5 cross 5, 7 cross 7. You are gradually increasing like the neighborhood of your kernel. And on the x-axis here, we have like different kernels. We have mean filtering, Gaussian filtering, and median filtering. So generally, you can see that as you increase the neighborhood of the kernel, your Gaussian filtering is actually doing a better job as compared to mean filtering. But if you look at the median filtering, even with like 3 cross 3 kernel, it almost removes like all the salt and pepper noise we had in this input image. Okay, so if you think about this, why that's the case, in median, we actually don't care about all the values which are present in the neighborhood. We don't perform any averaging. We just pick the median. So in that sense, we are not changing the pixel intensities. So it's not performing any smoothing or that kind of operation. So it's just like picking the value, which is like the most prominent in that neighborhood, and just using it. And because it's like coming from the actual image we had, so the quality is pretty good. Okay, so now one drawback of median filter is if you think about this, mean filtering, Gaussian filtering, whatever you do, it's a linear combination. So the computation cost is not that high. But in case of median filtering, to get that pixel value, you will have to first perform sorting, right? So you'll have to take all the values in that neighborhood and perform some kind of sorting to get the median. And that sorting operation is actually computationally expensive. And that's why we don't do median filtering. Now, another important point, I think, when you solve your programming assignment on filtering, this will come up. What should be the size of your kernel? All right. And there's a very simple rule of thumb for Gaussian kernels. Whatever standard deviation you have, you just set like half width of your kernel to 3 standard deviations. Okay. So the intuition behind that is, for example, you have this green Gaussian kernel. All right. So this is kind of a thicker. Thicker means it has a bigger standard deviation because the values are deviating a lot. And if it's like a very high peak, for example, like this blue over here, it means that it has a small standard deviation. All right. So what happens is you don't, of course, want like a very big kernel which has all the values 0. Okay. So what we try to do is we try to clip at this location where the Gaussian curve is actually going close to 0. And that value actually turns out to be 3 sigma. And that's why what we do is we take 3 sigma here, 3 sigma here, and we just discretize this curve. And that will give you your Gaussian filter. And the same holds true even if you have a 2-dimensional kernel. All right. Now, another interesting question is like what happens if we have edges, because we can't place your kernels on the corners. And there are many different solutions to that, and we should actually not worry about that. So we can actually extrapolate those values. We can actually even just make them all 0. Okay, that's called clipping filter, something like this. This is your smoothing filter. You can wrap around, which means that you can rotate the values, the pixel values. You can consider that this was like a cylinder, right? And what will happen is your values will navigate from right to left and maybe top to bottom. Okay. Then it will look something like this. And you can see that it's happening because the pixel values were being propagated from this right edge to the left edge. And you can see that the pattern is actually exactly like this. And that will be the filtering operation. You can actually copy edges. That's actually also easy. You can just extrapolate the pixel value towards the right or top or left. Okay. It will be something like this. You can see like the values are actually just extending. Okay. And there are many other ways, like you can do all that.